What's the difference between x equals 3 and x is greater than or equal to 3? So if we were to represent this on a number line, this first one is just that single point right there. There is no answer other than the one at exactly that same spot. Okay? Whereas on the other one, it's not just that spot, although that spot is included. And it's everything over here to the right. So if I were to try x equals 4 in here, and I substitute x equals 4, does 4 equal 3? No. But if I try 4 over here, 4 greater than or equal to 3. Is that true? Yes. So all of these points satisfy that equation, and these are called inequalities. They're not necessarily equal. Hopefully this is all review from something you've done before. What if I had this? X plus 4 is less than 2. So I'm going to take some number and add 4 to it, and the answer has to be smaller than 2. Can I simplify this down so it's a little bit easier to understand? All you need to do is treat it as though it was an equal sign and solve for x. So subtract 4, and I'm left with x is less than negative 2. So on my number line, negative 2, how would I represent x is less than 2? Does negative 2 count? Is negative 2 part of the solution set? No. So how do I distinguish between 2 counting, negative 2 counting, and negative 2 not counting? I draw a circle around it. If you fill in the circle, that means that that particular point is part of the answer. If you leave it open, then it's everything just off of that, just smaller than that. And then I would shade all of this stuff over here. So in theory, I should be able to pick a number that's on that space and plug it in, and it should work. For instance, negative 10. Is negative 10 plus 4 less than 2? Yes. So I must have done it correctly. And everything on the other side of that open circle should also not work. So let's try 0. Plug in 0. Is 0 plus 4 less than 2? No. Is 2 going to work? Why won't 2 work? It's an open circle. It's not part of the answer. We put 2 in there. Or sorry, negative 2. I meant negative 2. Negative 2 plus 2. I can't even talk. Negative 2 plus 4, thank you, is not less than 2. It's less than or equal, but it's not less than 2. So negative 2 is not one of the answers. All right, let's do something a little bit harder. 6x minus 5 is greater than or equal to 11. Bad idea. How about 13? Add 5. 6x is greater than or equal to 18. Divide by 6. X is greater than or equal to 3. So at 3 on the number line, open a closed circle, and I shade everything to the right. Everybody understands that, right? Okay, let's do something a little bit different. 10 is greater than 2x minus 6 divided by 4. What am I going to move first? Nope. So the first thing that happens to x is 2x. But if I'm going to peel this back from the outside in, what do I move first? The 4, and then the 6, and then the 2. So if you look at x, according to order of operations, the first thing that hits the x is a 2, the second thing that hits the x is negative 6, and the third thing that hits the x is the 4. when we pedal backwards, we're going to undo the 4, and then the 6, and then the 2. So multiply by 4. And over here I have 40 greater than 2x minus 6. Add the 6. 46 equals 2x. Divide by 2, and it's not equal, sorry. It's greater than. 23 is greater than x. This it's a little bit backwards. So at 23, we know it's an open circle. Which way do I shade? Left or right? Everybody agree left? If we read it, x is less than 23. So we want to represent every number that's smaller than 23, which would be to the left. Now, if you're ever unsure about which way to shade, it's really easy. All you do is plug in 0, and you see if 0 works or not. 0 is the easiest number to plug in. If we plug in 0, 0 times 2 is 0, minus 6 divided by 4 is negative 6 over 4. Is negative 6 over 4 less than 10? Yes. So 0 works. If 0 works, then everything around 0 should also work. Does that make sense? Well, what if it was shaded the other way? What if, so if I get rid of that shading, if it looked like this, if it's shaded this way, can I still plug in 0? Yeah, but when I plug in 0, what do I want to happen? Well, let's try it and see what happens. So we have 10 less than 2x minus 6 over 4. Let's plug in 0. 0 minus 6 over 4 is 10 smaller than negative 6/4. No. So what does that tell you about 0? This is not an answer. Is that what we wanted? I was just checking to see if my answers were correct, and I shaded to the right, so I wanted 0 to not work. Does that make sense? Is that not clicking? So, in general, let's say I shade this way and I'm a little unsure, and 0's over here. If you plug in 0 and it doesn't work, that's a good thing, because you said that all the answers are on the other side. But if you actually shade over here and not over there, and you plug in 0, you want it to work. Okay? Another one I want, and this one kind of confuses people, so pay attention closely. Negative 2x is greater than 6. How do I solve that? Divide by negative 2. X is greater than negative 3. So negative 3 I should shade. So let's shade to the right. And it's always a good idea to double check to make sure that you did it right. Let's plug in 0. Should 0 work? Yes. I plug in 0. Is 0 bigger than 6? No. Where did I go wrong? Yeah, that's kind of strange, huh? It didn't work. It's supposed to work, but it didn't work. So I drew my arrow the wrong way. Here's the problem. Let's say I don't like negative numbers. So I'm going to add 2x over there, and I get 0 greater than 6 plus 2x. Now I subtract 6. Negative 6 greater than 2x, and I divide by 2. Now I have negative 3 greater than x. Is this and this the same thing? They're not the same. One says x is bigger than negative 3, and the other one says x is less than negative 3. So negative x's cause problems, and here's what the problem is. Before, we had a balance, an equal sign. And we said everything on one side of the equation is equal to everything on the other side. And that's true whether you pile up weights, so both of those weigh the same amount, or it was also true if I times all of these by -1 and they ended up being balloons that pulled in this direction. Right? If you had a balance and you had weight on both sides and it was balanced, you know that the weight on each side is the same. But if you had a bunch of balloons on both sides, as long as the amount of balloon force up is equal on both sides, it's still matched. So you could turn weight into balloons by timesing it by -1, and as long as it was balanced, you didn't break any of the rules. But now we're not working with an equal sign. Now we're working with an unbalanced system. So we have our balance that looks like this. We have lots of weight on one side and a little bit less weight on the other. What happens when I turn those into balloons? So let's say this weighed 10 pounds and this weighed 5 pounds. If I turn those into balloons and I have a balloon that's pushing up at 10 pounds and a balloon that's pushing up at 5 pounds, what's going to happen? Now, my balance that used to be low on the left side is going to switch and be low on the right side. So anytime you switch from positives to negatives, whenever your weight is positive and you switch to negative, or your weight is negative and you switch to positive, that inequality sign switches. Does that make sense? So over here, oh, did I really? Is it no? Huh, I broke it. I don't know. Yep, I guess it died. So when I had -2x greater than 6, if you subtract or if you add the 2x over, then the balance remained as it's supposed to be. But, and this is the rule you need to remember, whenever you multiply or divide by a negative, the inequality changes directions. When I divide by -2, it now becomes x, switch that around, less than -3. And when I graph that, before it went to the right, now it will go to the left. And if you try, say, -5, it should work. Is -2 times -5 greater than 6? Yes. So the rule is, if you multiply or divide an inequality by a negative, essentially you're changing the type of weight that you have. You have an unbalanced system, and you're turning whatever's there, whether it's weight or balloons, into whatever's not there. And when you do that, it's going to change directions. The heavy side changes. So if you multiply or divide by a negative, you flip the inequality. Let's do one more of those. So x over -3 minus 6 is less than or equal to 5. What should I do to this to start off with? Subtract 6. X over -3 is less than or equal to -1. Now what? What's holding the x and the -3 together? Divide, so we need to multiply. And remember the rule, if you multiply or divide by a negative, we get x is less than or equal to, nope, I said it, but I didn't do it. Now it's greater than or equal to 3. So when I draw that, open or close circle? No circle, which way do I shade? Shade to the right. And that is the 0.3. So let's try 4. 4 should work. 4, well, that's bad. Let's try 9. 9 is easier to see. So 9 divided by negative 3 plus 6. 9 divided by negative 3 is negative 3, and negative 3 plus 6, is that less than 5? Yes, so that works. You want to make sure 0, if you want to try another one, you could try 0. 0 should not work. 0 divided by negative 3 is 0, plus 6 is 6. Is 6 less than 5? No, so we must have done it correctly. Okay? All right, get to work.